This video is how to perform a hypothesis test in Quantum Excel using the Advisor wizard, and at the end we will also use the AutoTest. The data set I'm going to use for this is the time to process material from 4 different suppliers measured in seconds, and then it is obviously in columns A, B, C, and D. First, I'm going to select the data, so I will click on cell A1 through D11 and select Hypothesis Test Advisor Wizard. When I click on Advisor Wizard, Quantum Excel will ask me a sequence of questions to help me choose the correct test. The first question is my data quantitative or qualitative? Because my measurement is time to accomplish a task, time is quantitative, so I will leave quantitative selected. Had my data been binomial, such as the results of a pass-fail test, then I would have selected qualitative. The next question is, am I interested in variability or spread of the data, or would I like to do a hypothesis test for the mean or median or location of a data set? Because we often need to know before we do the mean median test, if we're willing to assume equal variance, we usually start with the variability or spread of the data first, and then we go back and do the mean median second. So I will leave it selected as variability. The next question is the data normally distributed? If you don't know, you can do test of normality, such as the Anderson-Darling test or the Shapiro-Wilk test. There's another video for performing a normality test in Quantum Excel. In this case, I'm going to say that the data is normally distributed and click Next. The next question is, how many samples do you have? For this data set, I have 4 different suppliers, so I have more than 2 samples, so I will select more than 2 samples. Now, Quantum Excel gives me the answer or the test that best fits for my particular problem. And in this case, it's Bartlett's test. You can see that the hypothesis tested, the null hypothesis is the variances are all equal, and the alternate hypothesis is the variances are not equal. Note the subscripts on the variances are equal. It says under the null hypothesis, sigma 1 equals sigma 2 equals ... sigma n. The fact that it goes out to ... sigma n means that it's a more than 2 sample test. At this point, all I have to do is click Run to run Bartlett's test. When I do, Quantum Excel will again ask me the data range. Had I not selected it in advance, then I could select it now. And when I click on Finish, Quantum Excel will run Bartlett's test. The null hypothesis is that the variances are equal, and the alternate hypothesis is the variances are not equal. The p-value is 0.98, and since 0.98 is much larger than the alpha crit or decision criteria 0.05, then Quantum Excel displays insufficient evidence. It is very confusing, but at the same time important to note that Quantum Excel does not say accepted. The words not accepted are not being displayed next to the null hypothesis. Hypothesis test can tell you with some level of confidence that the variances are not equal, but they cannot ever tell you that the variances are equal. So at this point, most experimenters would say, lacking sufficient evidence to say that the variances are not equal, we will assume that the variances are equal. With a very small sample size, it's very difficult to indicate that variances are not equal. So you have to be careful about your assumptions at this point. However, I'm going to assume that the variances are equal as I proceed through this video. Now that I know that I'm willing to assume that the variances are equal, I will go back to my data set and I will continue for the mean or median or location of the data. So once again, I click on Stat Tools, Hypothesis Test, Advisor Wizard. The beginning is all the same, so I still have quantitative data. Now I'm interested in mean, median, or location of the data. I've already answered the question, is the data normally distributed? So we'll see, again, assume yes. And then Quantum Excel asks how many samples we have. Because in this case, we have 4 different suppliers, we have more than 2 samples, so I will click on more than 2 samples. And now Quantum Excel asks, do the data sets have equal variance? Because of the results of Bartlett's test, I'm now willing to assume that the data sets have the same variation. And you can see that Quantum Excel is already telling me that it's going to do an ANOVA for the analysis method. I will click on Next. Quantum Excel gives me the correct test, which was a one-way ANOVA test. Notice that the null hypothesis is that mu1 equals mu2 equals ... mu n, which means that we can test if multiple population means are the same, versus the alternate hypothesis is that at least one of the means is different. If I click on Run, Quantum Excel will ask me the data range. Had I not pre-entered the data range, then I could put it in now. However, I've already entered the data range, so I will just click Finish. Quantum Excel displays the resulting one-way ANOVA. we can see that the null hypothesis is there is no difference in population means. Another way to write that would be that mu1 is equal to mu2, which is equal to ... mu(n). And the alternate hypothesis is that the means are different, and only one of them has to be different in order for the alternate hypothesis to be true. The p-value is 0.0023, and because that is less than the decision criteria or the critical alpha of 0.05, Quantum Excel says next to the alternate hypothesis accepted and next to the null hypothesis rejected. So we are now very confident that the means are different. Quantum Excel also has a feature called an AutoTest. And essentially an AutoTest does everything in this video that I just demonstrated, but automatically. So if I click on Stat Tools and then Hypothesis Test and run AutoTest, now I select my data range and I click Finish, and Quantum Excel will do everything that I just did automatically. And Quantum Excel gives me the results of the AutoTest. At the top, Quantum Excel gives me a summary of what it has accomplished. So the first thing it did was it ran the Shapiro-Wilk test to see if there was evidence if the data was normal or not normal, and it found insufficient evidence to conclude the data sets are not normal. A very important point about the AutoTest, and it's highlighted at the bottom, is that just because the p-value is greater than 0.05 for the Shapiro-Wilk test does not necessarily mean that the data is normal. So you have to be careful about your assumptions, but the Quantum Excel AutoTest does make that assumption, so you need to be aware of that if you're going to use the AutoTest. It then says that Bartlett's test says there's insufficient evidence to conclude that the variances are different at the 0.05 level, and so the AutoTest will assume equal variances. I made the same assumption when I was running through the wizard. And then finally, it tells me that the one-way ANOVA test rejected that the means are equal at the 0.05 level. And once again, there's a note down here. If the p-value is less than 0.05, from a test for normality or variance, it assumes the data is not normal or equal variance. And if the p-value is greater than 0.05, then the data is normal or equal variance, depending on if it's doing a normality test or an equal variance test. This is the one that you need to make sure that you're willing to accept. And again, there's an article about it listed right here. If I scroll to the right, Quantum Excel does a box plot for me. And so I can see the box plot for the 4 different suppliers. And then to the right of that, you can see that it does the full statistics from the one-way ANOVA. And then slightly to the right of that, you can see the full statistics for the Bartlett's test. And that is how you perform a hypothesis test using the Advisor Wizard or the AutoTest in Quantum Excel.